Hello and welcome to the lecture that is Introduction to Nanotechnology. In this lecture, we will see the attributes of nanotechnology studies and what are the different things that comes under nanotechnology. So, firstly, the definition, which is the nanotechnology. It is a study of fundamental relationship between physical properties, phenomena, and material dimensions in the nanometer scale. So, basically, it's about studying the properties studying the properties of materials which are in nanoscale. That is at least one dimension in between 1 nanometer to 100 nanometer. And also its phenomena that is exhibited by these materials. So nanotechnology, it facilitates for designing um, small features in a given space. So in a given space, as it allows small features, that is nanomaterials or in the range of nanoscale, so it will enable us to design the functionality in a given space. So within a small space, we can achieve a greater functionality because of nanoscale materials. And materials in the nanometer scale, these are very much different. Sometimes they exhibit physical properties that are distinctively different from that of bulk materials. For example, if we take a material, suppose gold material, if we take in this graph, we can see the melting temperature as the particle size increases, and when we enter into nanometer range, as the particle size decreases, the melting temperature is also decreases. From here on, it rapidly starts decreasing. And another example is that the lattice parameter of the materials also changes. That is, lattice parameters decreases. Lattice constant of the material decreases. Here, if we see a a material with the radius in nanometer here, when we go below the 1 nanometer, the lattice parameter starts to decrease rapidly. So, for compared to bulk materials, the nanomaterials have low lattice constant. For nanomaterials, the fraction of surface atoms will be more compared to that of bulk. In case of bulk, the material is large, so the surface atoms fraction is less in the total atoms. But when we go to nanoscale, the number of surface atoms are more, so the surface energy will be different compared to that of bulk materials. And surface energy, so this is equal to the amount of energy required to break the bonds to form the surface. So on the surface, we don't have atoms above it. So in order to achieve that, the bonds has to be broken. So overall material, how much energy is required to break bonds of all the atoms on the surface, that is equal to surface energy, and it plays a significant role in thermal stability. And so here thermal stability is that it's a resistance of the material to degradation of ductility and toughness when exposed to thermal conditions like heat or environmental conditions. That's the thermal stability. Hence, the surface energy. So the thermal stability of nanomaterials is different compared to that of bulk materials. Here you can see the surface energy versus radius of the nanoparticle for a particular material. So as the radius of the nanoparticle is decreasing, the surface energy is increased because the number of surface atoms is more compared to in nanomaterial is more compared to that of bulk material. And compared to bulk materials, the nanomaterials achieve stability at a lower temperature. So when we reduce the size of ferroelectrics and ferromagnetics, they achieve stability at lower temperature compared to that of their bulk. So these ferroelectrics and ferromagnetics at nano size, they will lose ferroelectricity and ferromagnetism because they get stable at low temperature. And another phenomena is that bulk gold, it doesn't exhibit any catalytic properties. Whereas when the gold is reduced to nano size and the gold nanocrystals, these are excellent low temperature catalyst. For example, on SOIO2 substrate, where we can oxidize the CO. CO oxidation is being taking place here, and the gold nanoparticles are acting as a catalyst for CO oxidation to take place. So, what are the different prospects or attributes of nanotechnology? So, firstly, we can see that studying of nanostructure materials using electron microscopy or tunneling microscopy, uh, transmission electron microscopy. So, study of the nanostructured materials using any electron microscopy. And the another attribute could be like growth and characterization of thin films. So what all you can expect in nanotechnology? These are few of them, like few important ones. So another would be growth and characterization of thin films, like developing uh, thin films and then characterizing them using characterization tools. That falls under nanotechnology. And bottom up approach in material synthesis, such as self assembly. Here in the bottom up approach, we have atoms or molecules or simple building blocks. Their size is less than zero point 0.1 nanometer. Then we are forming clusters. Clusters are the materials having uh, size in the range of 1 nanometer, and 1 nanometer to 10 nanometer, and from these we are developing nanomaterials. So this is a bottom up approach. It is called self assembly. In this way we are synthesizing nanomaterials. So this is something that we do in nanotechnology. And also the application like drug delivery, where by putting drugs inside carbon nanotubes, we are going to send inside of the cell. So this is a carbon nanotube. This is drug. This is drug A and drug B. Both are kept in the carbon nanotube, and in, it is sent into the cell. So that's how drugs are being delivered. Medicines are being delivered, and another could be micro electromechanical systems and lab on chip. So here, micro electromechanical systems is a small. We know electromechanicals. What are electromechanical systems? When we design them at nanoscale, then that is called MEMS, micro electromechanical systems. As you can see here, this is one MES. It had a transducer, physiochemical signal, immobilization surface, and biorecognition, amplifier, and processors. The typical things that you find in a electromechanical system or a device, but we are able to design in a micro scale. The other could be lab on chip. So it is basically a chip which acts as a lab, basically by giving some sample input to this. Ultimately, we get the overall result. So, if you consider a lab, in the lab we give sample, and there are different equipments in the lab which takes our sample and give us the final result. But here is chip, one chip is acting as a lab. Means because of nano feature, we are able to achieve that. So, and the another future prospects, these are future prospects like miniature submarines in the bloodstream. So these will be using for in medical field, for different purposes. Miniature submarines in the bloodstream, and also small self-replication nanorobots which monitor the human body. So, so these are different uh, things that are present in nanotechnology. Thank you so much for watching this video, and if you find any other prospect related to nanotechnology, please write in the comments, and or do subscribe and press on the bell icon to get more videos. Thank you so much.